All right, guys, this is Chapter P, Section 3. We're going to talk about polynomials and special products. We're going to talk today about combining like terms. Remember, we talked about that before a little bit when we sometimes I liken like terms to saying like the same last name, something like that. And we're going to ignore the coefficient. You need to understand that the like term, the term has to be identical. So like if you have x squared y, your other term has to also have x squared y. These are the same, but if you had like xy squared and x squared y, those aren't the same because x is to the first and y is to the second, so those are not like terms. All right, so we're going to go through some examples here. So if you notice here, I have a binomial, and I'm adding. So as long as we're adding, all we have to do is just go through and collect all the like terms. So I have 4y squared and a negative 7y squared. Well, 4 plus a negative 7y squared is going to give me negative 3y squared. And then I have a negative 3 and a positive 9. So negative 3 plus 9 is just plus 6. And then that's all the combining we can do because 6 doesn't have a y squared. Negative 3 does. All right, same thing. I have this first parenthesis, the second parenthesis, and I'm adding. So we're just going to combine like terms. I have a 5x cubed and a 1x cubed. Give me 6x cubed. I have a negative 7x squared and a positive 2x squared. So negative 7 plus 2 is going to give me plus 5x squared. I have a negative x all by itself, so that's just going to stay as negative x. And then I have a negative 3 and a positive 8, so negative 3 plus 8 is going to give me a positive 5. And there we are. All right, the next example is a little bit different. The way that this is different is there is a minus sign here in between. So before we can combine like terms, we have to distribute this minus sign throughout. So this is going to become 2x squared plus 1, and I have minus x squared, minus the negative is going to give me plus 2x, and then minus and plus is going to give me minus 1. So now I can combine all my like terms. So I have a 2x squared and a negative x squared. That leaves me with just x squared. I have this positive 2x all by itself, so plus 2x. And then I have a positive 1 and a negative 1, and those just cancel out. So we're left with x squared plus 2x. All right, same concept. We're going to take this first this first expression here in our parenthesis, and it's minus the second one. So again, before we combine, we have to distribute this negative sign throughout everything behind. So I have 7x to the fourth minus x squared minus 4x plus 2. And then I'm going to distribute that negative sign. So negative 3x to the fourth. Negative times the negative is positive 4x squared. And then minus 3x. And then now we can go through and combine like terms, sorry. 7x to the fourth, negative 3x to the fourth is going to give me 4x to the fourth. I have a positive 4x squared and a negative x squared. That's going to give me plus 3x squared. Negative 4x and a negative 3x is going to give me negative 7x. And then I have just plain old plus 2 hanging out right here. And again, nothing else can be combined. Those are all now as far as we can simplify it. All right, in example number 5, we have a bunch of things going on. So the first thing I want to do is combine what's inside this bracket first. So I'm going to rewrite my y cubed plus 1, and then I have my minus sign. And then I'm going to go ahead and simplify in here. So we're adding these two binomials together. Any like terms I have, I can combine. So y squared, there's nothing else that has a y squared. Nothing else that has a y, so just 3y. Here I have a positive 1 and a negative 7. That's going to give me minus 6. So now I have a subtraction problem. Well, subtraction is just distributing the negative and then adding. So we're going to distribute this negative sign throughout. So y cubed plus 1. Then I have minus y squared minus 3y minus the negative is going to give me plus 6. And now we combine like terms. I have 1y cubed. That stays. I have 1 negative y squared, so minus y squared. I have 1 negative y, so minus 3y, and then positive 1 and a positive 6 is going to give me plus 7. All right, guys, after adding and subtracting, we're going to go to multiplying. So when you multiply polynomials, you're going to multiply the coefficients and multiply the variables with exponents. We're going to add exponents if the bases are the same. We're going to multiply binomials by foiling, and we're always going to combine like terms. So if I have a problem like number 6, this is just a distribution. You're going to take this x and distribute it to everything on the inside. So if I have x times 3x squared, well, x times x, the same basis, you're going to add exponents. This becomes 3x cubed. I have x times negative x, going to give me negative x squared, and then x times 1 just gives me a positive 1. So we have 3x cubed minus x squared plus x. Next, we're going to distribute. I have my negative 3x on the outside. So negative 3 times 5 is going to give me negative 15. X times x gives me x squared. Negative 3x times 2 is going to give me minus 6x. And that is the most combining that you can do. And number 8, we're going to take y squared and distribute it to everything. So I have 4y squared gives me y cubed. Then I take y squared to 2y. This gives me plus 2y cubed. And then I have y squared to negative 3 is going to give me minus 3y squared. And that is as combined as we can go. Now, the same thing on number 9. You're still distributing, or distributing, however you want to say it. You're just the 2y cubed is just at the back. So I'm going to say 2y cubed times 2 is going to give me 4y cubed. And then 2y cubed times negative 3 is going to give me negative 6y to the 4th. You could rewrite that if you wanted to, so your variables go in descending order. This would be negative 6y to the 4th plus 4y cubed. You don't have to. I'm just saying you could if you wanted to. All right, next, number 10. This is just a binomial times a binomial, so we're going to FOIL. So first times first. X times x is x squared. First times outer, x times 4 is plus 4x. Inners, negative 8 times x is just going to give me negative 8x. And then the outers, negative 8 and 4 is going to give me positive 32. And then we can combine like terms in the middle. So you have x squared minus 4x plus 32. Number 11, same thing, a binomial times a binomial. So 3x times 5x is going to give me 5x squared. 3x times 7 is plus 21x. Negative 2 and 5x is minus 10x, and negative 2 and 7 is minus 14. Sure, my pencil's not working there. And then we can combine in the middle. So 15x squared plus 11x minus 14. All right, again, 12. First times first, so 2x times x is 2x squared. 2x times 5 is plus 10x. Negative 4 times x is minus 4x. Negative 4 and 5 is plus 20. Combine in the middle. We have 2x squared plus 6x plus 20. And number 13. First times first. So 28x squared. 7x and negative 3 is minus 21x. Negative 2 and 4x is minus 8x. Negative 2 and negative 3 is plus 6. Combine like terms here. I have 28x squared minus 29x plus 6. All right, 14 is the exact same kind of problem. It's just a little longer, a little messier, but you're going to do the exact same thing that you guys have been doing. We're going to distribute. You're just multiplying a whole bunch here. You can write this either way you'd like. You can write it on top of each other, or you can write it next to each other. So 14, I'll do it horizontally where I write next to each other, and then 15 I'll do vertically so you guys can see either way. But what I'm going to do is take x squared and distribute to everything in the second parentheses. So x squared and x squared is x to the 4th. X squared and 2x is going to give me plus 2x cubed. X squared and 2 is going to give me plus 2x squared. So now I'm going to take 2x. So negative 2x and x is going to give me negative 2x cubed. Negative 2x and 2x is going to give me negative 4x squared. Negative 2x and 2 is going to give me negative 4x. And now I'm going to take the 2. So 2 times x squared is plus 2x squared. 2 times 2x is plus 4x. And 2 times 2 is plus 4. And then now we can combine like terms. So I have 1x to the 4th. That's all I have. That's going to... All right, so let's look at our x cubes. I have a positive 2x cubed and a negative 2x cubed. So those will just cancel. So our x squareds, I have a positive 2x squared, a positive 2x squared, that's 4x squared, and then a negative. So those will cancel. Good. So So then I have a positive and a negative 4x. Those will cancel, and then I just have my positive 4, so just plus 4. So that whole big mess just comes out to be positive x to the 4th plus 4. So now we're going to... All right, this next example, guys, instead of writing horizontally like I did in 14, I'm going to distribute and then write things vertically, keeping our like terms in the same columns. You'll see in a second. So 2x squared and 2x squared is going to give me 2x to the 4th. 2x squared and 3x is going to give me plus 6x cubed. 2x squared and 2 is going to give me plus 4x squared. Now I'm going to take my negative x and I'm going to distribute. So negative x and x squared gives me negative x cubed. Notice how I write it underneath my cubes. So negative x and 3 is going to give me minus 3x squared. And negative x and 2 is going to give me minus 2x. Now I'm going to take the 4. So 4 times x squared. I'm going to write it right here under 4x squared. 4 times 3 is going to give me plus a 12x. And then 4 times 2 is 8. So now we're going to combine vertically. Instead of left to right, we're going to go up and down. So 2x to the 4th plus nothing is 2x to the 4th. 6x cubed minus 1x cubed gives me positive 5x cubed. Excuse me. 4x squared minus 3x squared is 1x squared plus 4 is going to give me plus 5x squared. Negative 2 and 12 is going to give me plus 10x, and then I have plus 8. So there we have 2x to the 4th plus 5x cubed plus 5x squared plus 10x plus 8. And we cannot combine anything else because nothing else has the same last names. All right, now we're going to talk about some things called special products. Products means multiply. So these are some special things that happen when you multiply things together. Now, if you notice here, number 1, or the first example, this is the difference of squares, difference of perfect squares. You have the same numbers or letters in your parentheses, but what is different is one is going to have a plus sign and one is a minus sign. It could be minus plus, plus minus, it doesn't matter. But when you have this scenario, what happens when you multiply these two binomials together is you come out with a squared minus b squared. The first term squared minus the second term squared. So in our second two examples, it's similar to the difference of squares, but it's not. It's the two binomials are the same. If you have a binomial that is raised to the second power, that means you have two of them. So in a case where you have a binomial raised to the second power with a plus sign in the middle, you square the first term, you square the last term, put them at the end, you got plus signs in the middle, and then you multiply a and b together and multiply it by 2 in the middle. Notice there is a plus sign in both. Same exact thing happens for a minus b squared. You square the first term, put it at the front, square the second term, put it in the back. But in the middle, you multiply the two terms times 2, but there's a minus sign in the middle. With the difference, excuse me, when you have a plus b quantity cubed, that means to the third power, or a minus b to the third power. There is a pattern to that as well. If you notice here, this is the pattern. If you see it, great. If you don't, you could just multiply it out, however you want to do it. We've talked about, you guys might have learned about Pascal's triangle. The pattern for Pascal's triangle is 1, 3, 3, 1. And that is going to go on your, your terms. I'll show you when we go through these examples. So I look at this first one, and you would typically FOIL this out. You would say 2x times 2x is 2x squared, and then multiply 2x and negative 3, and then 2x and positive 3, and then they cancel out. But if you notice, I want you guys to try and start learning the difference of the perfect squares. I see I have the same a, the same b, I have a plus sign and a minus sign. So what this is going to work out to is the first term squared, so 2x squared minus 3 squared. So remember, this 2 goes to the 2 and to the x, so this becomes 4x squared minus 9. That's your difference of perfect squares. You guys can just write that out. Same thing here. I have 4a, 4a, 5b, 5b. The only thing that's different, excuse me, is the sign in the middle. So this is, again, difference of perfect squares. So you have 4a squared minus 5b squared. Well, you have to distribute your 2 to both things. This becomes 16a squared minus 25b squared. Again, your difference of perfect squares. This is saying 6x minus 5 2 times. 6x minus 5, 2 times. So again, this is a pattern. You're going to take the first term, 6x, and square it. You're going to take the last term, negative 5, and square it. But the middle term is going to be a times b times 2. So it's minus 2 times 6x times 5. So this becomes, this goes to both, so 36x squared, negative 2 times 6 times 5 is going to give me negative 60x, and then I have plus 25. When you square a negative number, it becomes positive. So 36x squared minus 60x plus 25. Same thing here. I have, what this is saying is 5 minus 8x times 5 minus 8x. It's 5 minus 8x quantity squared. So you take the first term, 5, and you square it. You take the last term, negative 8, and you square it. To get that middle term, you have minus 2 times 5 times 8x. So I have 25 negative, excuse me, negative 2 times 5 times 8. That's going to give me negative 80x. And then when I square this, this becomes plus 64x squared. All right, guys, so here we have 8x plus 3, quantity squared. That means 8x plus 3 times 8x plus 3. So remember the pattern. You're going to take the first term, which is 8x, and you're going to square it. You take the last term, which is 3, and you're going to square it. And since I have a plus sign in the middle, I'm going to say plus 2 times both terms together, 8x times 3. So this becomes, when we distribute, 64x squared. 8 times 3 is 24, times 2 is 48, so 48x, and then plus 9. It's much easier if you know the pattern. Super helpful. All right, when we come to 21, you see that this is raised to the third power. So this is really 3x plus 2 times 3x plus 2 times 3x plus 2. All right, Pascal's triangle, there's a pattern for this. The pattern for this is 1, 3, 3, 1. That's the exponent that goes on each term. You remember this pattern. So what we're going to do is we're going to take the first term. I like to write this out vertically. So I'm going to say 1, 3, 3, 1. I'm going to take my first term, which is 3x. So 3x. And then I have my second term, which is 2. Now this pattern tells you we are raising this to the third power. So you're going to start with 3 on your first term. So this is third, second, first, 0. Anything raised to 0 power is 1. On the bottom, the second term, you're going to start with ascending exponents. So 0, 1, 2, and 3. This can be the first power. So let's distribute. I have my coefficients get squared and cubed as well. So this becomes 27x cubed. This is 9x squared. This is 3x. This is 2. 2 squared is 4. 2 cubed is 8. And now we just multiply down. So 1 times 27x cubed and 1 is just going to give me 27x cubed. 9 times 3 is 27. Times 2 is 54. So plus 54x squared. 3 times 3 is 9. Times 4 is so plus 36x. And then I have 1 times 1 times 8 is plus 8. So we use Pascal's triangle to simplify a problem that could be very difficult if you are just writing it out as it's written, like this: x minus 2, x minus 2, x minus 2. You could multiply all those together, but notice that this is raised to the third power, so we're going to use Pascal's triangle. The pattern is 1, 3, 3, 1. My first term is x, so I'm going to write out my x's. My second term is negative 2. And since we're raising to the third power, we're going to start with the exponent of 3. So 3, 2, 1, 0. Everything to the 0 power is 1. The bottom row starts with ascending exponent. So 0, 1, 2, 3. I like to do any simplifying I can. So negative 2 to the first power is just negative 2. Negative 2 squared here is 4, and negative 2 cubed here is 8. So now we multiply down. 1 times x cubed times 1 is x cubed. 3 times negative 2 is negative 6, so minus 6x squared. 3 times 4 is plus 12x, and then 1 times 1 times negative 8 is going to give me minus 8. So my answer here, when I multiply this all out, is x cubed minus 6x squared plus 12x minus 8. All right, I look at this problem and I say, oh my gosh, what are we getting here? I have 3a squared, 3a cubed, minus 4b squared, plus 4b cubed squared. For ease of things, let's go ahead and make this a cubed. So I notice that I have 3a cubed, 3a cubed. I have 4b squared, 4b squared. So this is just the difference of perfect squares. So think about what we do for this. We take our first term, 3a squared, 3a cubed, I'm sorry. 3a cubed, and we square it, minus your second term, 4b squared, squared. So when we distribute this and we square, 3 squared is 9. Raise the power to a power, I get a to the 6th. Minus, we're going to distribute here, so 4 squared is 16. And 2 times 2 is 4. So 9a to the 6th minus 16b to the 4th. Again, you can look at this problem a variety of different ways. The first thing I see here is a difference of perfect squares. So I know that this is going to become x squared minus y squared. And then I'm multiplying it by x squared plus y squared. So again, this is the difference of perfect squares. So we're going to take that first term, square it, minus the second term, and square it. So this becomes x to the 4th minus y to the 4th. All right, this last problem, it says in words, subtract negative 7x to the 4th plus 5x squared minus 1 from 2x to the 4th minus 10x cubed minus 4x. So what that is saying, guys, is take this from that, meaning you have 2x to the 4th minus 10x cubed minus 4x minus negative 7x to the 4th plus 5x squared minus 1. So again, you can do this horizontally or vertically, whichever you choose. It's totally fine. But the first thing we need to do is distribute this negative sign throughout. So this is going to be 2x to the 4th minus 10x cubed minus 4x. Negative minus a negative is going to give me plus 7x to the 4th minus 5x squared minus a negative is going to give me plus 1. So now when we combine like terms, I have 2x to the 4th and 7 of them gives me 9x to the 4th. I have a negative 10x cubed. Nothing else has a 10x or an x cubed, so I'm going to say minus 10x cubed. Then I have a negative 5x squared. Nothing else has an x squared with it, so minus 5x squared. I have a negative 4x. All right, nothing else has just an x. And then I have plus 1. So that's a big old problem. 9x to the 4th minus 10x cubed minus 5x squared minus 4x plus 1. There's nothing else you can combine here, guys. This is it. So what I want you to do tonight, I want you to work on your homework. Any questions that you have, I will go over. I will be in school on Thursday, so I will go over anything from P3 and what we're going to do P4 tomorrow. I'll give you some review problems. I will go over anything you need to review on Thursday and Friday, and we're going to move our test back to the following week, Tuesday, when we come back from Labor Day weekend.